Hello, good afternoon. It's been a very long time, and I would like to share this new topic with you, and it is called time series analysis. Forgive me, the semester has been a very long semester, and I am very, very tired, and I know you are also tired too. So we will do things quick here. I can promise you that there's no question on time series in my section B, but section A has a lot of questions in time series. So I will rather ask you to read the slides. I don't have any exercise attached to it. Read it very well so that it will help you to answer the section A. But I will take my time and then explain some of the salient points in it so that it will not be difficult for you to grasp when you read it. Okay, time series is like regression analysis. But in a time series case, the independent variable is time. The independent variable is time. So in time series, you are measuring how something changes over time. You are measuring how something like a temperature change over time. You are measuring how, let's say, the price of items change over time. So in time series analysis, everything is over time. So it is defined as a set of observations measured at successive points in time or over successive period of time. Others define it as a time series is a sequence of measurement taken every hour, day, even month, quarter, year, or at any other regular time interval. But so when we do that, what does it help? How does time series help us? So it has two main importance here. So first, it is to help you to understand past events. So past behavior of the data. So if you are going into, let's say, trade, a certain trade, you are going to sell, let's say, car tires, and then a particular trader has data on how he has recorded how the sales of how he sells the tires. You can use time series to know how that particular business has been performing in the past. And then the second reason is for you to use it to forecast. So if you know how the sale of tires has been performing in the past, then you can use time series to forecast ahead, as in how the business will also boom. So there is this example that I want us to look at. So in a certain week 1, this was the sale. Week 2, this was the sale up to week 10. This was the sale for a certain drugs in it. So when we plot this on a chart, you see that these are the week numbers, these are the sales. You realize that from week 1 to week 3, there was an increase, and there's a decrease, increase, decrease, increase, sharp decrease, and then an increase. So this is a time series plot that will help you to look at the nature of the business. But this chart cannot be used to make a decision because it is made up of what? Zigzags. You can just plot anything and then it can't give you a correct estimation as in what will happen in the future, because it goes down and it goes up, it goes down and it goes up. So there is a certain line of best fit that if it is drawn across, then it is because it is a line, it can be used to make predictions or a forecast in the near future. Because of that, every time series is divided into 4 components or patterns. 4 components or patterns depending on how the chart looks like. So if you look at this, for instance, You know, this is the actual readings on the chart, but the line of best fit, which is this, gives us the trend. So you can see that, oh, from year 1 to year 13, the trend is that sales has what? Increased because it has gone up. In other cases, it may come down. But this small rise and fall, small rise and fall are fluctuations. But if you see this one, the height itself, you see that it is a bit lower, so it is an irregular one. It is not the usual one that happens. So an irregular trend is something that comes out of the blue. So let's say you are measuring, let's say, sales over a year, over so many years, and you get to 2020, and because of COVID-19, the sale has gone a little bit low. That one is an irregular fluctuation. Okay, so we have seasonal and then cycle. The seasonal is similar to cycle, but seasons happen within a year. So you see that year 12 and year 13, there is a season. It goes up, comes down. So it's like the sale of, let's say, apples within a year. That is seasonal because apple may have a season, so maybe it may come more within a year, and so people will buy more, and then it may go within a year. You get it? By cycle is the same thing, but it is over 1 year. So cycle has happened to be like maybe a situation where business booms during, let's say, a leap year. So you can see that over the years, it will be down, but when it is a leap year, it will come up, and then the other ones, it will come down when it's a leap year. So this one is over years, and it becomes what? A cycle. So this graph summarizes the 4 components of the patterns that are in time series. And I believe these ones, when you read them, it will help you a lot. Now, what I want us to talk about is, okay, this one too is there is multiplicative mode and then additive. That is involves the trend, cycle, seasonal, and then irregular. How a model that composes or that decomposes this. So if you have a graph like this, a model can be used to decompose it. And this is a theoretical model, so I don't want to go into it that much. But one thing that I want us to look at is the forecast error. Forecast error. So the forecast error is only the difference between the actual value and then the forecast value. So let's say before 2021 or 2020, you predicted that, oh, the GDP will be less than, let me say our Ghana's inflation will be 9.6. But the actual value when we go to 2020, it wasn't 9.6, it was, let's say, 10.0. So the forecast error is the actual value, the 10.0 minus the 9.6. That one will give you that error that you are looking for. And if you get a wider error, it means your forecast was poor. And if you get a lower error, it means your forecast was good. So that is why forecast error is very important, and it is used to judge what? Forecast accuracy. So when you subtract the forecast from the actual and you find the average of it, you get what? Mean error. But we know that it is made up of negatives and positives from our previous one, we were finding variations and the rest. So the negatives may cancel the positives and you end up getting a smaller value. So the best way is to use the mean absolute error. Mean absolute error. And that one, when the value is negative, you change it to positive. I think the example will demonstrate it well for you to see. Okay, so these are the mean square error. This one, after finding the difference, you square it and then you find the average of the square. And this one is the mean absolute percentage error. That means you divide the actual over the error and then you find the percentage of it. And then there is this observation, which is the naive forecasting method, and it is the one that uses it. This one brings all of them together and draw a simple conclusion. I think the example will help us. So from this particular question, we are going to use it to find our mean absolute error, this one, mean square error, and then mean absolute percentage error. So you can see that when we come here, the naive forecast, it is just a shift. So the succeeding year is equal to the previous year, actual value in the period T. So here, in this succeeding year, it is equal to what the actual value of the previous year. So it is just a shift to 10, 15, 13. So these are the naive forecasts. That means you use the old year to forecast the succeeding year, the 2019 value, to forecast what? The 2020 value. And when you do that and you find the difference is, this is the actual, this is the forecast. You get the forecast error, which was in the model like this, actual minus forecast. So you get these values, and then when the absolute value means that change all negatives to positive. So you change this to positive, positive, you get that. And then the square error means that you square this. When you square all these ones, you get that. So you find the total, you get this, you find the total, you get that. And then you find the mean absolute percentage error for each one. So this is the error, absolute error. You divide it by what? The actual sales, and you multiply it by 100, and you get this value. So this one divided by this times 100, you get this. And after that, you add all these percentages and you get this. Okay, so for you to be able to calculate this error, naive forecast accuracy error was a forecast accuracy. So mean absolute error was this 80. This 80 divided by how many observations? We start from the 1, 2, 3, 4, 5, 6, 7, 8, 9. So divided by 9 will give you what? The mean absolute error. And then the mean square error is this value. This value you get here divided by that. And then mean percentage error will be, absolute percentage error will be this value divided by the average, which is 9, which will give you 7.2%. So the forecast percentage error is 7.26%. Okay. I wanted to end here, but I want to combine this lecture as 2 lectures so that I don't have to do one next week. I'm tired. Okay. So this one would have been for next week, which is moving averages and exponential smoothing. So some of the time, to be able to find a trend, you have to do something we call a moving average. So with that same question, so like the moving average means that you find the average of the observations downwards. So if you want to find 3 averages downwards. I think with the examples, it will explain it better. So let me use the examples to explain the moving average. So it is still the same question, but they said using 3-period moving average. So 3-period moving average forecast is, what is the forecast for week 4 to 11? So it means that this value plus this, you add this 3, you find the average, you get this. And because they are saying it's from 4 to 11, this plus this, you add this, you find the average, it comes to the 5th line. This plus this, you add it, you find the average, it comes to the 6th line. So it comes to the succeeding ones. And then when you do that, then you begin to perform the usual operation. So these are the values that you have here. So you find the error associated with them, the error associated with them, the error associated with them. and then you find the absolute value, and then you also find the square of them, and then after that you find the percentage, absolute percentage error, which is this value divided by the actual times 100, and that one will give you this. After that, then you can perform your usual calculation, the mean absolute error, this one, which is this calculation, 53.3 divided by the number of observations, which is 7, and then you get that, and then you get this. So you can see that this mean absolute percentage error, in this case, it is lower. It is lower compared to the previous one where we did with the naive one. You can see that the naive one was 7.26%. So the moving average is a better smoothing approach than the naive one because it gives us a smaller percentage absolute error. Okay. There is also another one which is weighted. It is just similar to that of the moving average, just that at every stage there's a value that there's a particular weight that you add, you multiply by. So on this note, you can multiply this one by a certain weight, 0.2, 0.3, 0.5, and then you add them and you get the succeeding one. So the weighted one is just like the moving averages, but this one it is weighted, like you have values that will help you to calculate. Okay. One important one is the exponential smoothing. You can see that for you to give the succeeding forecast or the forecast for the succeeding year, so let's say 2021, there is a particular weight also called the smoothing constant, which you will multiply it with. If you are looking for that of year 2021, this one will be the actual value for year 2020. And then this one will be the forecast value for year 2020. And then that one you will use it to calculate for the forecast downwards. Okay, so this smoothing constants will be given and it must lie between 0 and 1. So when you look at this example, the same example, the smoothing constant, first one is 0.1. So which means that if here is 0.1, 1 minus 0.1 will give us 0.9. So in that case, we have 0.1, 0.9. The first year, actual year becomes what? F2. So F2 is here, which is 100. This, and then actual year in year 2 is what? 115. So 0.1 times 115 plus 0.9 times 110 will give us this value. So when you come to the forecast 4, here becomes 3, here becomes 3. So this one becomes the actual for year 3, which is this. And then the forecast for year 3, which is that. You get it. So then you also use this one to smooth it. So at the end of the day, you get these values. And then when you calculate, so you report those values here, and then you can find the error, the absolute error, the mean square error, and then the percentage absolute error, and then you total all of them. This one is when you have the alpha to be 0.8. It is the same approach. You calculate them. You find their error, absolute error by changing negatives to positive, by squared error by squaring these ones, and then percentage by this one divided by the actual times 100 will give you this. Then after that, you find the mean absolute error, which is this, mean square error, which is divided by their average numbers, which is this, and this is that, this is that, this is that. So you realize that when you use alpha equals 0.8 and alpha equals 0.1, this smoothing had a lower percentage absolute error compared to that. You get it? So this one is a better moving average method compared to that. Yeah. So I think this brings us to the end of the lecture, and please learn it and you will see a lot of this in your objectives, and I've missed you all, and thanks for having you. The next time we'll be meeting, I'm sure we'll be doing our revision. We'll be doing our revision, and the things that I need you to know, I'll let you know, but I think you know a lot. You know a lot, so enjoy your day, and then goodbye.